Okay, here we're going to talk about the normal model or the bell curve, also known as the Gaussian distribution. You guys all know this shape. A lot of natural phenomena follow a bell curve. Test grades often follow a bell curve. Most people are right here. You have some that are really high and some that are really low. Our symbol for a normal distribution looks like this: N mu comma sigma. N means normal distribution. Mu, that's the Greek letter mu. That is not an M and that is not a U. It's kind of like a U with this extra tail here on the left. Mu stands for the population mean, and sigma, that's like a little circle with an extra line on top, stands for the population standard deviation. So normal distributions are symmetric, meaning the mean equals the median. So the mean is right here in the middle. It is also the median. So half of the population's above average and half are below average. As an example, IQ is a normal distribution with mean 100 and standard deviation 15. Now IQ, we really don't know what IQ measures. We know it doesn't measure success at all. So we're going to talk a little bit about IQ during the next few videos, but we're not really talking about smarts versus dumbs. We're talking about just a test that people take and what kind of scores they get on those tests. So something interesting about the normal model is it will follow what's called the empirical rule. And these are all approximations. If you want more accurate numbers, they're right here. But approximately 68% of your entire population will be within one standard deviation of the mean. So IQ, the mean was 100, the standard deviation was 15. So 68% of people have IQ. I went 15 below 100 and 15 above 100. So 68% of the population is between those two numbers. 95% approximately of your population is within two standard deviations of the mean. So if we start at the mean 100 and I go down 15 twice and up 15 twice, now I've covered 95% of the entire population, are between here and here, between 70 and 130. If you go 3 standard deviations on either side of the mean, so again, we're only for IQ, mean was 100, go down 3 15s to 55, start in the middle, go up 3 15s to 145, from here, 55 to here, up to 145, is about 99.7% of the entire population. Very few people are below or above those numbers. Now we could break this down further if we wanted. For example, since we've got 68% of the entire population in this middle region right here, that leaves 32%, 100 minus 68, that we haven't counted for. But this thing's symmetric. So all of this below has to be half of 32, which is 16, and all of this has to be 16. So 16% are above 115, 16% are below 85. We could play the same game. We had 95% up from 70 up to 130. 95% of the whole population. That leaves 5% total we haven't accounted for yet. 100 minus 95, 5 left over. But that has to be split between these two little tails here. So this chunk right here should be about 2.5%, 2.5%, and this should be approximately 2.5%. So about 2.5% of the population is above 130. Below 115, we just said above 115, here was 16%, So that leaves 100 minus 16, 84% below. What if we wanted to go above 100? 100's right in the middle because our mean is 100. So half the population's above 100, half are below. That's on purpose. The test is designed so that the average score is 100.